Now that we've seen some very basic operations and working with array lists, I want to talk to you about how an array list dynamically resizes. So we talked about that in there's no hyphen there. We talked about this in the first and the last video, but now I want to talk about what exactly we mean by how it does that, because obviously it can't just be magic, and indeed it's not really magic. So what is going on? Well, when we create a list, let's say we create a list of integers called L, we'll do new array list. Well, just like with an array, we're going to have a heap model, so a memory model, where L is going to point to somewhere in memory that an array list stores, or an array list is located. Sorry, not stores. But the thing is, an array list is more than just a collection of elements. It's not like it's just a contiguous block of data. In fact, it's something a little bit more powerful than that. So, an array list is actually sort of like it's just like a container of other information about it. So, for example, one of the things that an array list stores is its size. Okay. Additionally, there's also just some other information. But the most important thing is that array lists under the hood are just arrays themselves. So, inside of here, an array list is going to have another reference to somewhere else in memory that actually stores an underlying array of values. Okay? So, let's say that the initial array list starts off at a capacity of 5. Okay? So, that means that the size is 0. So when we do something like, for example, we do L.add 42, that will put a 42 inside of our array. Okay? It goes inside of our array list, which then gets put inside of the array. The value gets put in the underlying array, and the size therefore changes to 1. Of course, before it was 0. Okay? So let's say we do L.add of 1, and then 6, and 24, and 120. Basically just recreating the example that we did in code. Okay? So 6, 24, 120. Now we've hit a bit of an impasse. Well, not yet. We're about to hit an impasse. So then let's say we do, let's try and clean that up. Let's say now that we do L.add 720. Now we're at a bit of an impasse. So first of all, our size is now going to be 5 instead of 6, or sorry, 5 instead of 1. But now the problem is that our array can't fit that new value. So what is it going to do about that? Well, we already said that this array cannot change. It's impossible for this specific array to change. But what Java can do, or what the ArrayList class can do, is create another array, a larger array with more slots. Okay, so let's just assume that there are more slots over here. Actually, we do need a... So let's assume that what happens is the array list is going to first create a new array that it's going to then copy each of these elements over to. Okay, so we're going to copy the elements from the old array into the new array that is now larger. Okay, very good. And then we're going to insert or add the new element to the next available slot, which would of course be here. Okay, then the last thing it's going to do is change what this list points to. Okay, so instead of pointing to this array list, this array, it's going to point to this array. Okay, So it's important to realize that, again, the L is pointing to a block in memory where there is some information stored. Okay, and this would also get updated to 6. Okay, but under the hood, there's going to be some information that's stored about the array list. And like we said, that's the size. There's some other properties, but the most important thing is that underlying array. Okay, so, well, yeah. So there's not really much further to say. There's really there's 3 steps. So we first create a larger, or not we, but how the ArrayList class handles, or the ArrayList data structure, how it handles this resizing problem. So under the hood, it first creates a larger array, larger than the existing array. The second thing it does is it copies values from the old array to the new array. Okay, and that can be done with just a simple for loop, because you can say, like, you have indices 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Then we're just going to have a for loop from I equals 0 up to the length of the old array, and then just copy those into the new array. Okay, and then we reassign the reference. So, what do I mean by the reference? I mean this thing, right? So, like we said, the ArrayList data structure will point or reference some array out in memory, okay? And by default, like we said, it's going to reference this one up here, right? But when we resize it, we don't want to then have it reference this one. We want it to instead reference this one, right? Because this is the new one that we created to sort of take the place of this one. Okay? So that's how it happens under the hood. Now, you may be wondering, well, what happens if we then remove an element? So if we want to remove the element at, let's say, index 1. Well, what exactly is Java going to do? Well, we kind of talked about this in the last video, but it's important to really understand how removals and insertions work. So, what Java's going to do is it's going to shift all of the values down by 1 value. Okay, so instead of being 42 with a blank spot, 624, 120, 720, it's going to be, let's just erase them all. We're going to shift everything down by 1, and it's going to be 6, 24, 120, 720. Okay, so now this spot is free. Okay, very good. So, what happens if we want to insert an element? So, that would mean that we call, let's say, 1000 with the value. So we pass the, let me make sure I tell you this correctly. Add, okay, so the index comes first. Okay, sorry about that. So if we want to insert an element at, let's say, index 2, and we want to insert the value 1000 there, then that would mean that we're going to set index 2 to be 1000, and then everything else is going to shift to the right. Okay, so let's see what that looks like. So let's just erase this. So first we would shift everything to the right. So this would be 720, 120, and then 6, and then, well, wait a minute, sorry, hold on. That's not right, sorry. Yeah, so it'd be 720, 120, 24, I don't know where I got the 6 from, and then the 1000 would go here, okay? Now hopefully it's easy to see why just setting an element like l.set, so we want to set the element at index 0 to be 2000, hopefully you see why that would not require any resizing, because we would just change what this value is in the array list, which would then change the value in the underlying array. Okay, so again, those are the three parts. The array list, when it needs to resize, it will create a larger array, it will copy the values from the old array to the new array, and then it will reassign the underlying array reference.